All right. Today we're doing this amazingly fun question with double angles. So we're given this great hint which says write 3 as 3 cos squared theta plus 3 sine squared theta. So 3 does equal 3 cos squared theta plus 3 sine squared theta, because if you factorize out the 3 from the right-hand side, you get 3 outside of cos squared theta plus sine squared theta, which equals 3 times 1, which equals 3. I just thought I would share that fun fact because it does look a little bit alarming at first and people have got alarmed. So there is no need for panic. Everything is still mathematically correct. Okay, so the question then becomes cos 2 theta plus, well, 3 is now 3 cos, 3 cos squared theta plus 3 sine squared theta. So that's our 3 equals 3 sine 2 theta. Okay, now because I've got cos squareds and sine squareds in my question, that's why I'm going to decide to expand cos 2 theta using the cos squared theta minus sine squared theta expansion instead of just the 2 cos squared minus 1 or the 1 minus 2 sine squared. Okay, so because I've got both and the question is specifically said to introduce cos squared and sine squared via this hint, I'm going to use both in this expansion. So here we go. We have cos squared theta minus sine squared theta. That's cos 2 theta plus 3 cos squared theta plus 3 sine squared theta equals 3. And I need to expand this sine 2 theta, which is obviously just 2 sine theta cos theta. Okay, so far I'm very satisfied. All right, now I need to collect like terms. So I have 4 cos squared theta plus 2 sine squared theta on the left-hand side, and on the right-hand side I get 6 sine theta cos theta. Okay, so far so excellent. Let us give ourselves some more space. Okay. Then I'm going to put everything on the right-hand side. The reason is that I feel like this is going to become a quadratic, a really unfortunate one, due to the fact that I have a cos squared, a sine squared, and a sine cos. So that's like an x squared, a y squared, and an xy. So really it's going to become a quadratic in both x and y. So I'm going to put them on the all on the left-hand side first. So I get 4 cos squared theta minus 6 sine theta cos theta plus 2 sine squared theta equals 0. Okay, then I'm going to see if a quadratic works. Fun fact, helpful handy hint, h cubed, it does. So I'm going to let x equal cos theta and let y equal sine theta. Okay, and then I'm going to rewrite my question. Okay, more room for mathematics, always helpful. Back to red. So therefore, I have 4x squared minus 6xy plus 2y squared equals 0. Okay, so then I could also actually, to be honest, let us factorize out the 2. So because then I don't have to think of as many numbers when I'm factorizing the quadratic in both x and y. So let us take out 2. So we get 2 outside of 2x squared minus 3xy plus y squared equals 0. Still fun. Then I have to think of how I'm going to factorize out this monstrosity. So I'm going to do product sum factor. So I'll use my blue for that. My product is going to be this times this. Remember that y is a constant in an xy quadratic. So my product is going to be 2y squared And my sum is minus 3y. Why? Because it is. So my factors are going to be, okay, I've got a negative sum. So and a positive product. So I'm going to have two negatives multiplying together to give it a positive product. So, and minus 2 times minus 1 is positive 2. Minus 2 plus minus 1 is minus 3. So I'm thinking that our factors are going to be minus 3y and comma minus y. Minus 3y minus y is, I did not say that right, unfortunate. Minus 2y. Minus 2y minus y is minus 3y, that's fine. Minus 2y times minus y is 2y squared. I'm happy, hooray. Okay, so therefore I need to rewrite out my quadratic and expand the middle term, just like I would with an ordinary quadratic. So I've got an ordinary non-monic quadratic. So I've got 2 outside of 2x squared minus 2xy, that's the 2y there, minus xy, and that's the y, plus y squared equals 0. Let's just check that that adds up correctly. Minus 2xy minus xy is minus 3xy. So that's fine. Okay, maths is still happening. And then we need to non-monic quadratic this further with a large bracket. So 2 outside of large bracket because I need to factorize by pairs. So common factor of the first, highest common factor of the first pair is 2x. X minus y. I've got a negative here, so I'll take that out and hope for the best. Y is the common factor here, so minus y. I'm left with x minus y. That works. I'm so pleased. Now I need more space. Okay, so inside my bracket, I've got x minus y is my common factor to both terms. Now that this has become 2 terms. And then I'm left with 2x minus y equals 0. Now, null factor law. 2 does not equal 0. Fun. So therefore I can say either x minus y equals 0 or 2x minus y equals 0. Okay? But we let x equal cos theta and y equal sine theta, so I need to do that. So, but x actually equals cos theta and y actually equals sine theta. Okay, so I need to deal with that. I need to put those back in. So cos theta minus sine theta equals 0, or 2 cos theta minus sine theta equals 0. Okay, we are getting so close to this ridiculous answer to this ridiculous question. So here I have cos theta equals sine theta. Divide through by cos theta. Whenever I have coses and sines, I like to turn them into tans because then I only have one function and then you can, you know, solve it. Equals 1. So tan theta equals 1 happens at theta equals pi on 4 in the first quadrant, and also in the third quadrant because tan is positive there as well. So pi plus pi on 4. Okay, that's fine. And then actually, to be honest, we're going to have to work in degrees because of this next answer, and probably because the question told me to work in degrees, and I just think in radians automatically. The original, all of the question, because this is part J of a multi-part question. I need to work in degrees. Fine. Theta equals 45, 180 plus 45 makes me sad. Okay. Or I have 2 cos theta equals sine theta. So sine theta over cos theta equals 2. Tan theta equals 2. Theta is inverse tan of 2. And once again, we need to find this in the first or the third quadrant. So shift tan 2, close bracket. Check your calculator is in degrees. Otherwise, bad things will happen. Theta equals 63 degrees, 26 minutes, or 180 plus 63, 26 minutes. And of course, you would simplify the 180 pluses to get your final answer. I hope this explanation was as pleasing to you as it was to me. I always like a complicated question. Have a lovely afternoon.